All right, today we're diving into one of the oldest tricks in the cyber attacker's playbook, but one that is still incredibly dangerous: SQL injection. We're going to treat it like a digital heist and figure out exactly how the thieves are picking the locks. So it all boils down to this almost unbelievable question. How can a single, simple line of text, something you could just type into a login box, have the power to bring an entire website to its knees? It sounds crazy, right? Well, that's exactly what we're here to unpack.
So, at its heart, SQL injection is a really clever, really sneaky trick. It finds a weak spot where an application doesn't bother to check what a user is typing in, and by exploiting that trust, an attacker can slip in their own malicious commands and basically get the website's database to work against itself.
To really get how this attack works, we first have to understand what it's targeting. Just think of a website's database as its high-security vault. It's where all the good stuff, all the valuable information, is kept.
Now, the language that the website uses to talk to this vault is called SQL. That's short for Structured Query Language. Every single time you log in, or you search for a product, or even post a comment, behind the scenes the website is sending SQL commands to the database to either grab or save that information.
And you gotta understand, SQL is powerful. It can do pretty much anything with data. It can insert new stuff, select what's already there to take a look, update it to change things, or just straight up delete it forever. It's basically the master key to the entire data kingdom.
So here's the kicker, the crucial point. The vulnerability isn't actually in the database, and it's not in the SQL language itself. The problem is a flaw in the web application. It happens when the application is way too trusting, when it just blindly takes what a user types and passes it straight into an SQL command without cleaning it up or checking it first. We call that an unsanitized input vulnerability. And if an attacker pulls this off, the consequences are, well, they're severe. They can completely bypass login screens, steal sensitive info like usernames, passwords, credit card numbers. They can change or delete data, and in the worst-case scenarios, they can even get full control of the server itself.
Okay, so theory is one thing, but how does this actually play out in the real world? Let's get our hands dirty and walk through the anatomy of a classic attack. We're gonna see how they use a digital skeleton key to pop that vault right open.
All right, so normally when you log in, the application takes your username and password and builds a question for the database. It basically asks, hey, can you go select user data from our users table where the username is Jason and the password is Springfield? The database looks for that exact match. If it finds it, you're in. Super simple, and when done right, secure.
But here's where the attacker makes their move. They forget about using a normal username. Instead, they type a very specific, carefully crafted, malicious string of characters right into that login field. Now to you and me, it might just look like a typo or gibberish, but as we're about to see, every single character in there has a job to do.
And that malicious code is often something ridiculously simple looking, like this: blah or 1 equals 1 dash dash. That's it. That little piece of text is the skeleton key. The vulnerable application takes this, no questions asked, and plugs it right into the SQL query we just saw.
And this is where the magic trick happens. The query is now broken. It asks the database to find a user where the username is blah or where 1 equals 1. Well, think about it. When is 1 not equal to 1? It's a condition that is always true. And that double dash at the end? That's a comment in SQL. It tells the database to just ignore everything that comes after it, including the part that was supposed to check the password. And just like that, the vault door swings wide open.
And you know, that login bypass we just saw, that's just the beginning. It's just one tool. Attackers have a whole toolkit full of different SQL injection techniques they can use, depending on how the system is set up.
They usually fall into 3 main buckets. First, you have in-band. That's the most direct. The attacker gets the data sent right back to them through the website itself. Then there's inferential, which is also called blind injection. This is more like playing a game of 20 questions. The attacker asks a bunch of true or false questions to slowly, piece by piece, figure out the data. And finally, you have out-of-band, which is super stealthy. It tricks the database into sending the stolen data to a totally different server that the attacker controls.
Okay, that's enough about breaking in. It's kind of scary, right? Let's flip the script. How do we stop it? Let's talk about the defenses and how we can build a proper fortress around our data. This right here, this slide shows you everything you need to know. On the left, you see the vulnerable code, where the user's input is just carelessly stitched right into the command. But on the right, you see the secure code. It uses something called a parameterized query, and that is the key to the whole thing. And it all comes down to this one single golden rule. You always treat user input as just plain old data and never as part of your executable code. Parameterized queries make this happen. They send the command template to the database first, and then they send the user's data separately. The database is basically told, hey, here's the command, now go plug this data into the blanks. Because the data is never part of the command itself, it can't be executed. The skeleton key is useless.
So building on that golden rule, here are the key defense strategies. First up, input validation. Think of it like a bouncer at a club who only lets approved guests in. Next, the parameterized queries we just talked about, they are the absolute gold standard. Then there's enforcing least privileges. This just means the app's database account should only have the bare minimum permissions it needs to do its job. That way, even if an attacker gets in, they can't just delete everything. And finally, output encoding, which makes sure any data coming out of the database is displayed safely, so it can't accidentally run as code in someone's browser.
At the end of the day, the best defense isn't a single magic bullet. It's all about layers. Just like this diagram shows, real security has to be built in at every single level. From the firewall filtering the traffic coming in, to the web application cleaning up all the user input, all the way down to the database itself being locked down with minimal permissions.
And all this brings us to our final, and maybe most important question. We've known how to fix this for more than 20 years. The defenses are well known. So why? Why is SQL injection still, to this day, one of the most common and one of the most damaging attacks on the web? The answer, unfortunately, usually comes down to things like legacy code, a simple lack of awareness, or the tough reality that it only takes one developer making one mistake on one line of code to leave that vault door wide open.